I'd like to introduce Andrew. Andrew is a colleague of mine, one of the first Igor employees, and he comes with over 20 years of experience in the building controls and energy efficiency industries. Since he joined back in 2014 at Igor, he's focused on developing the customer service support department, product development, documentation, and PoE lighting installation best practices. Prior to that, Andrew began his career at Johnson Controls, where he served for 6 years within their controls division, working with building automation systems. Andrew then joined Quality Attribute Software as a senior software engineer, where he was later promoted to the director of professional services, and he oversaw all activities related to product development, project implementation, and customer satisfaction. In Iowa, this is very important to know that Andrew received his degree from Iowa State University with an emphasis on control system design. So with that, I'm very excited to have Andrew. Final reminder that if you have questions, put them in the Q&A chat function and we'll ask them at the end of the session. So with that, Andrew, it's all you.
Great, thank you, Kim. Well, excited to have everybody joining us today for our Igor PoE Hardware 101 webinar. Going to do a deep dive into the Igor PoE nodes and hopefully answer a lot of your questions, but I'm sure there'll be some still at the end. So my presentation should last around 40-45 minutes to give us a nice bit of time at the end to answer anything submitted in the Q&A. So with that, we'll kick things off here. So a couple quick baseline things here. We're going to be talking about PoE power levels and such a lot today. So wanted to highlight really the 60 watt and the 90 watt PoE standards or PoE power levels available. When I first started at Igor about 6 years ago, it was really just the Cisco UPoE proprietary standard that was available at 60 watts per port, but that was really the power level at which PoE lighting became a viable option. Previous to that, with just PoE and PoE Plus, those power levels really didn't make a lot of sense for lighting and such. But now that we've got 60 watts and more recently up to really 9,900 watts per PoE port available, then lighting is a much more viable option. So just covering a couple of basics there. So now, there we go. So quick slide on the Igor Nexos technology stack and such. And so this really covers the whole Igor Nexos solution from the top with our cloud portal down to the on-premise gateway server, to the PoE power sourcing equipment, to the Igor nodes, which we'll be covering today. And then the bottom line is all the peripherals and such that you connect to our nodes. So the nodes will be our focus today, but we'll touch a little bit on some of those other devices as well. So Igor PoE nodes, these, when we talk about a node, this would typically replace your typical line voltage driver in a fixture. But these can do a lot more than your typical line voltage driver. As you can tell by the number of terminal blocks and such on these nodes, we have a lot of I/O capability on them, well beyond just the basic driver functionality. And so right now, Igor has two primary series of PoE nodes. We have what we call our Rev 5 series, which is really our 60 watt standard series, and then our more recent Rev 6 series of nodes, which allows for up to 99 watts of input power. Both series of nodes and really, going forward, all future Igor nodes all carry a pretty standard set of UL listings, 2108 for low voltage lighting, 1598C for retrofitting line voltage fixtures, UL 2043, which is a very important one, the plenum rating, because that plays into the flexible mounting options with the Igor nodes. These nodes can be mounted in a fixture, on the outside of a fixture, up in the plenum. We see a lot of remote mounting applications with our nodes, and we'll kind of touch base on why that is a little bit later on. Then, of course, UL 924 are the emergency lighting standard, and so that's right now is based upon a centralized power backup emergency lighting solution. So generator, inverter, UPS, providing that centralized backup power to the PoE PSE, which is then powering the nodes. And then, of course, we have our Igor daisy chain capability, which we'll cover a little bit later on. I do want to mention that all of our nodes carry an industry standard 5-year warranty on them, but we have had extensive testing done on them, which shows a projected lifetime into the 15 to 20-year range. So very reliable, very well-tested designs. So a few more high-level things about Igor nodes and what makes our nodes special, unique in this industry. One of them is our software programmability. So with the same node, same physical device, you can program it for different milliamp levels, different inputs and outputs for different sensors and such, wall switches, relays, etc. Very flexible, and all of these this programming can occur over the network. So you don't have to physically access the device. You can use some different features to identify its IP address, and update its programming. From a dimming control standpoint, full range, 1 to 100% dimming control, and our UI does let you select the increments of that dimming. So standard 1%, but you can get fine grain into 0.1 or even 0.01 increment percentages via the gateway UI. So if you really have some display lighting, something that you really want to get dialed in, you can use that feature. And we offer 3 different dimming control modes, CCR or constant current reduction. We have 12-bit DACs on our nodes, which offer very fine grain control of that current level. PWM or pulse width modulation, which I think most people are familiar with. And we also have a hybrid mode, which uses CCR for about 90%, the top 90% of that dimming range. And then down at the bottom 10%, we switch over to PWM, because one of the focuses in our node and firmware development has been on that very smooth fade to off features of our nodes and our LED driver control and such. So that's something that we hang our hat on there. But along those lines, our node firmware also meets the IEEE 1789-2015 recommended practices for driving LED fixtures, essentially flicker, to reduce flicker from that. So something else that is very important to our design and our solution. So now we're going to get into the Rev 5 nodes, and I'm going to switch cameras real quick because I want to give everybody a close-up view. So I'm just going to stop my screen sharing so that you get a full screen view. Oops, 1 second here, and switch my camera here. So everybody should be able to see. I've got 3 Rev 5 nodes along the top here, and then a Rev 6 node here. But our first section here, we're going to talk about our Rev 5 nodes. I want to give everybody a nice up-close view of this. Sorry, this is backwards to me. But you can see, nice compact design. It actually has a break-off mounting tabs, top and bottom. So if you need to fit this into a junction box, you can simply break off those tabs and put it in a standard 4-square junction box. Screw down terminal blocks on this model, accepting, depending on if it's the LED drivers, it'll accept, I think, to 14 gauge wire versus the sensor and the wall switch terminal blocks on the sides are for smaller gauge, 18 gauge to 22 gauge conductors. So a couple different examples that we're going to cover in more detail of there, and then we'll get back to the Rev 6 node in that section of the presentation. So I am going to jump back to sharing my presentation here. All right, so everybody should see these are our Rev 5 network node models, and one of the key things that makes them a network node is this yellow PoE port, and so that's essentially where that Cat 5e, Cat 6, Cat 6a home run from that PoE switch, lands at the node. Standard RJ45 connection there. The circuitry is built into this for that PoE detection and such, so that it can get that power, that PoE power, granted to the node. And so we have 3 different I/O levels of the network nodes. We call them our max, mid, and min. And so you can tell based upon the terminal blocks that we've got some varying amounts of I/O between them. So it's you know, so we've got that to really offer some price differentiation. Sometimes you just need to drive a static, you know, fixture. Sometimes you need a little bit of I/O. Sometimes you need a lot of I/O. So we designed these different levels to give some flexibility for the solution. So going on to the next slide, we're going to have our device nodes, which physically are very similar, very much the same. But you'll notice they have two blue Igor ports. And so that's used for our Igor bus for daisy chaining these nodes. And so you can have up to 5 total nodes in a daisy chain. So that would consist of one network node, which is receiving the PoE power, and then transmitting that down the line to up to 4 more device nodes. And similar to the network nodes, we've got the same three different I/O levels here with our max, our mid, and our min there, terminal blocks. And really from a programming standpoint, you know, network nodes versus device nodes, you have the same programming flexibility for each of them. There's really no difference there. So that's one of the themes in our solution I hope you'll pick up on during the webinar today is we've tried to build a lot of flexibility into our solution to give our partners and owners a lot of power in when designing a system, installing a system, or using a system after installation is complete. These two nodes here are a couple of examples of our Rev 5 emergency node models. So the red label on any Igor nodes indicates that it's got that UL 924 listing. And so we'll go into a little bit detail later on how exactly that functions. But anytime you see a red Igor node, it's emergency lighting UL 924 listed. You will notice that we don't have a mid version of this node. We just have the max and the min, and that was really just based upon being able to handle tunable white lights with the max or single static lights with the min. And we didn't see a whole lot of extra I/O being placed on the emergency nodes. So that's why we just kept it at the max and min for both the network and device node versions. So moving on to the PoE compatibility. As I mentioned earlier, the Rev 5 nodes were designed for 60 watts of input power. I know, you know, based upon some IEEE standards and such, you know, if you're guaranteeing 60 watts at the port, then worst case scenario, home run length of 100 meters or about 328 feet, you know, you're only guaranteed, you know, based upon the type of cable used and such, you know, 53 watts at the end of that cable. But realistically, we wanted to design these nodes to handle a bunch of different you know, power scenarios. You know, even at the time when these were being developed, there were some PSEs coming out that could deliver more than 60 watts, say up to 70, 72 watts. So we really wanted to be able to leverage, you know, the full, you know, potential 60 watt potential on those nodes. And so looking at some of the compatibility down below on the difference between, say, a PoE network switch or some mid spans, you know, with PoE network switches, the built-in PD circuitry of the node will typically get it at least 2 pair power. And then if the PoE switch has LLDP capability, then our firmware will use LLDP to negotiate with that switch to get 4 pair power and that full 60 watts of power. And so that's kind of, you know, with PoE and the whole power negotiation process, there's at least, you know, there's a couple of different ways to do it. We also had ran into some mid spans or PoE injectors that didn't really have any software, smarts, LLDP capability. So we've got a dual PD signature built into the circuitry of these nodes as well that would allow those to detect on both pairs and grant that 4 pair power to these nodes in order to get maximum power out of that PSE port. So, you know, both of these are, you know, same node model numbers. These aren't, you know, covered by different node model numbers or anything, but just 2 different ways to get that PoE power granted to our nodes. Talking about the Rev 5 LED drivers, as you probably noticed on those previous slides, looking at the max, the mid, and the min nodes, the max obviously had 4 LED driver channels denoted by the terminal blocks along the bottom of the node, and the mid and the min nodes only have a single LED driver channel. But due to the flexibility of our programming, our firmware, our gateway software, on the max nodes, we can actually connect up to 4 individual fixtures to one max node. And as long as that's not exceeding 53 watts of total fixture power, then the node will operate just fine. In our gateway software user interface, those will show up as 4 individual fixtures. They can be assigned to the same lighting control space or separate lighting control spaces. It really allows us to separate the physical wiring of the system from the kind of the virtual setup. So sorry, I'm going to switch back to my integrated webcam here so you guys can see me. Oops, skipped ahead a slide. Okay, so a couple other highlights about the LED drivers. They are a constant current driver design for that circuitry. So we have very fine-grained control of the current flowing out to those LED fixtures. We're compatible with fixtures with a forward voltage range of V sub F of 12 to 48 volts DC. And we can program these nodes in 10 milliamp increments from 100 milliamps up to 1750 milliamps max output per channel. So it's a lot of flexibility, a lot of on-the-fly programming capability there. And from a fixture type standpoint, we've designed our solution to really be manufacturer agnostic. We want to play well with others. We want our solution to work well with other manufacturers' equipment, because we certainly don't want to manufacture, LED fixtures. We don't want to manufacture PoE switches, et cetera. We'll leave those up to the experts. And so we've designed our system from the ground up to be flexible from that standpoint. Getting into some of the some of those options and more details on those I/O options between the max, the mid, and the min node versions. And this covers both the network and the device, since they're the same from that standpoint. Obviously, the max had 4 LED channels versus 1 for the mid and the min. From an occupancy or motion sensor input standpoint, only the max and the mid have inputs for those types of sensors, and we designed it to handle either a dry contact signal or a 24 volt DC active high, so your typical blue control wire signal. And so those inputs are marked OCC1, OCC2. We also have some 0 to 10 volt analog inputs on the max and mid nodes, which allows to pick up a wide range of analog sensors. And the nodes, one thing I want to highlight, the nodes do have a 24 volt DC power supply built into them, so they can power these external devices with 24 volts DC and then receive these signals back. From a relay control standpoint, the Rev 5 Max nodes are our only node version right now that has relay control outputs. We've got 2 outputs on each, and so those can handle both latching as well as maintained, like single pull, dual throw type relays. And so that's very handy for whether you're, say, doing a hybrid lighting control solution, or maybe you've got some line voltage lighting you need to use a relay to turn it on and off with, or just some other peripheral devices that, say, like a pump or a valve or something that has more on-off control that you want to use. And then from a wall switch input standpoint, again, the max and the mid will allow up to 5 buttons, up to a 5-button wall switch to be wired to them. So get into some more specifics about some of those different device types that can be connected to these. From a fixture standpoint, typically single channel with a static CCT color or 2-channel tunable white fixtures can be pretty common. We have had some instances where more of like an RGB or RGBW type fixture was connected. One of the key things there is just that it has each color has is an individual channel. That it's not a common anode or common cathode type design. And so we've seen some interesting creative applications using that. Occupancy sensors, kind of based on what I talked about the last slide, dry contact, 24 volt active high. Analog sensors, a couple examples would be ambient light level sensor for daylight harvesting, temperature sensor, humidity, CO2, CO, O2 pressure, et cetera. Really, any analog sensor that can output a 0 to 10 volt signal, you can hook up to our nodes, and we can read that data in, harvest that data, store that data for you, such. And those relays, one other thing to mention about the relay outputs is that we are designed for 24-volt DC coil relays, so we can actuate those open and closed. The wall switch is going into a little bit more detail about the wall switch functionality. I mentioned on the last slide that we can do up to a 5-button wall switch, or you could actually connect multiple wall switches to the same node and program that node to let it know that, hey, you've got 5 1-button wall switches connected to you, or you've got a 2-button and a 3-button, etc. And so when that node relays those devices back to the gateway server, they will show up at the gateway as separate devices depending on how the node is programmed. So that gives you a lot of flexibility, similar to the LED drivers. You could program the node for 2 or 3 wall switches, and they'll be discovered as separate devices in the gateway software, and they can be assigned to different lighting control zones. So another example where we have a lot of flexibility built into the hardware and the software of our solution. And then the bottom line there is really some dry contacts, just whether we're picking up, say a fire alarm or some type of indicator from a third-party system, or getting into bed sensors, door closure sensors, water flow detection sensors, floor water sensors, etc. Some different examples of dry contacts that the Rev 5 nodes can pick up. So moving on to keep things going. Sorry, I thought I skipped a slide there. Okay, so now we're on our linear node models, and again, I'm going to switch my webcam and show you a little bit of a close-up of the Rev 6 linear node. So here it is here. So this node was really designed with tunable white troffer fixtures in mind. So we needed, to cover this form factor as opposed to kind of the more squarish Rev 5 nodes. We needed a linear design that would work with pendant lighting, with troffers, etc., and some other different scenarios. And so we took what we learned from Rev 5, we added and we improved some things on the Rev 6. And you'll notice on the end here, we've got a USB and RS-485 serial ports. So those offer us a lot of flexibility and communication capabilities when it comes to some other peripheral devices, because we, as soon as we released the Rev 5 line of nodes, we immediately started getting inquiries about what other types of devices can you connect to your nodes. And so, adding these USB and RS-485 connections made those external, non-lighting device connections much easier and such. So, going back to the presentation here, let me share my screen again. There we go. Oops, that's not the right screen. Sorry about this. How about this one? There we go. Okay. All right. So with the Rev 6 linear node models, we don't have quite the variety that we do in the Rev 5. We decided to just go with a max and a min version of each for both the network and device nodes. So kind of 4 total versions, at least of the non-emergency versions, versus roughly 6 of the Rev 5 nodes. And so one of the reasons for this was that we wanted, since these were really designed for tunable white fixtures, we knew we wanted to keep 2 LED driver channels on all node versions. And so then once we knew we were sticking with that, then really the only other thing to remove was the sensor IO points and this PoE power terminal here. I'll take a quick second to talk about the PoE power terminal, because really that, in conjunction with the USB and the RS-485 terminals, was part of what we learned from the Rev 5 line, where we needed a way to get that PoE power off of the node in order to power a peripheral device, whether it's at that 48 to 54 volt PoE voltage level, or maybe a lower voltage level. And so we can use a DC to DC step down transformer coming off of that PoE power port to drop it down to 5 volts, 12 volts, 24 volts, whatever that peripheral device needs. So that's been pretty popular addition and will be generally included on future node versions as we develop them out. So going on to the next slide, we'll have our Rev 6 linear emergency nodes, and so we have just two versions of this, a network and a device one, both in the max form factor. So it's got it's got the USB, it's got the RS-45 PoE power sensors and such, but the most important thing, of course, is the two LED drivers for that. So looking at similar to Rev 5 from a PoE compatibility standpoint, we want to take advantage of that maximum power available. We knew that the new IEEE 802.3 BT standard was on its way when we started designing this node. So we wanted to make sure our UL listing allowed us to consume all of that 9,900 watts of power available while still maintaining the NEC Class 2 standard. And so what we've got is from a PD design on these nodes, we've got a circuitry in there for 802.3 BT type 4 class 8 plus PD. So we can really take advantage of the full amount of power available from any PSC that it's connected to. So looking at some of the LED driver features, we have, as I mentioned before, two individually controllable LED driver channels. So you could connect two separate, say, static white LED fixtures to one of these nodes, or you could have one tunable white fixture connected to it, and it'll control just fine. Up to 75 watts output per channel for a total of 80 watts total between the two channels. So we definitely wanted to bump up the LED driver power capability with the Rev 6 node versus Rev 5 in order to drive larger fixtures, take advantage of the higher power available from the PoE home run. Again, this is a constant current driver design compatible with that forward voltage, fixture forward voltage of 12 to 48 volts DC. And with the higher power availability, we can bump up the amount of current that those drivers can output. So now we're up to a full 2 amps or 2,000 milliamps. And similar to Rev 5, really trying to be manufacturer agnostic with these nodes to be very compatible with multiple manufacturers' fixtures. Looking at some of the I/O differences between the Max and the Min, both have the two LED channels, but that's really where the similarities stop. We designed some universal sensor inputs for the linear nodes to really combine those three different types of signal inputs that we have discrete input points for on Rev 5. And so these universal inputs can individually be programmed for a dry contact, 24 volt active high, or 0 to 10 volt signal. So it gives us a lot of flexibility there to connect different sensor types to the same node. For wall switch inputs, essentially those would be connected to these universal sensor inputs, so we could have up to a 3-button wall switch connected to it. And so the Max node has the USB connection and the RS-45 serial connections, whereas the Min nodes do not have those connections. So looking at some of the device types, there's going to be a lot of similar device types that you can connect up to a linear node as with the Rev 5 nodes. 1 or 2 channel fixtures, occupancy sensors, analog sensors, wall switches. Really the only difference is that you can only do a 3-button wall switch on the linear, and we don't have the separate pilot light outputs on the linear nodes. Dry contacts, very similar connections. And so then once we get into some of the newer connection types that the linear node has that the Rev 5 doesn't, any Igor compatible USB sensors, such as a Bluetooth low energy indoor positioning and asset tracking sensors, some combo motion temperature light sensors have been developed, and others. So it's not quite like the USB port on your PC. I mean, it's got the same power and data capability, but we don't have the full every possible driver loaded on the node. Typically, we'll program the node based upon the type of device that's going to be connected to it or connected to that USB port. And similar on the RS485 port, Igor and our firmware developers have developed some Igor integrated protocols or integrations to these protocols for devices such as Somfy and QMotion motorized shades, 4D systems touchscreens, DMX 0 to 10 volt conversion modules for control of, say, line voltage fixtures and such. And so those are both the USB and the RS485 options are always expanding. We're always developing new features and implementing new features, so that list will continue to grow. Okay, so talking about some more high-level things about Igor nodes. At the beginning of the presentation, I mentioned our daisy chain capability, and that we could do up to 5 node, or it's really recommended that you limit your daisy chains to 5 nodes, which in a typical installation scenario, we typically find, especially if you're powering lights, you're going to run out of PoE power long before you hit this 5 node limit. 2 node and 3 node daisy chains are fairly common, but 4 and 5 node daisy chains are pretty rare, unless you're getting into, say, a monitoring only situation, whether it's, say, for a greenhouse or some other monitoring application where you want to have this daisy chain of sensors. Those are all drawing minimal amounts of power, a few watts each. Then you could max out that daisy chain. But along those lines, the node-to-node connections, these blue wires here, that's always going to be just a standard Ethernet patch cable, Cat5e 6A patch cable from an installation standpoint. Something that's already been pre-tested and reliable. Will make that installation go that much faster, commissioning go that much faster. One other key thing to highlight is that even with this whole chain and all the devices connected to it, it's really only consuming one IP address on that network. It's really just the network node that has the PHY and that does the communication back to that network switch for an IP address and all of the data flow and such. So you can really pack a lot of devices, a lot of lights and sensors, etc., onto one of these daisy chains while still only consuming a single IP address. And so kind of a summary here at the bottom, a total of 32, there's a limit of 32 total devices on a chain, which, so a device is going to be any light fixture or any sensor connected to it. So 32 is quite a bit to try and pack on all these nodes. As I mentioned before, you're probably going to hit your power limit before you hit that limit anyway, and so you've got 60 to 99 watts of total power available, depending on if your network node, whether it's a Rev 5 or Rev 6, and the PoE power supply powering that network node. So a few base level network communication items around the nodes. They are DHCP enabled. So when those nodes power up, when the network nodes power up, they are going to send out a DHCP request on the network, get an IP address back. Once it has that IP address, then it'll do a broadcast to the gateway server, discover the gateway server, and relay its devices up there. And so that's over both TCP and UDP. UDP is obviously the broadcast level type communication. Then once the communication is established, then we're using a CoAP protocol for that communication between the node and the gateway server. We used to use a UPnP, but CoAP provided us a much smaller packet size, which lowered our bandwidth requirements, lowered the amount of traffic on the network, and just improved performance overall. So allows for very fast, very speedy communication back and forth between the Igor nodes and the gateway server. The software that lives on the nodes essentially is called firmware, and so that is developed in-house. That is updated every 12 weeks in sync with our gateway software. So as we implement new features in the gateway software, those are also implemented in the nodes. And that firmware can be updated over the network via the Igor firmware updater tool. So I know, real creative name there, but that's what happens when we let the developers name the public facing tools. But yeah, that's a very good tool. You can literally scan the whole network for Igor nodes. It'll tell you what firmware version each node is at, and then allow you to pick and choose which ones you want to upgrade. Going into some of the individual node programming, as far as, okay, how do you program nodes for light fixtures, sensors, etc. We've got a few different tools available for that. Product Manager Lite was originally a kind of a bare bones tool, but it's a quick and easy, quick and dirty type tool. Field Configuration Utility was designed to kind of take some of the guesswork out of the programming. And then our more recent one is the Node Configuration Manager, which is a very powerful software tool that really allows us to add some of those more advanced peripheral devices, such as, say, the motorized shades, the Bluetooth, low energy sensors and such. Looking at some of the different modes that our nodes will operate in, one that really applies to lighting fixture OEMs is the manufacturing test mode. And this really allows them to do end-of-line testing to verify that the wiring between the fixture and the node is correct, that there aren't any issues with that light engine, that, if it's a static or tunable, if it's a tunable white fixture, that the colors aren't switched, etc. So that's all implemented via a simple RJ45 key that gets inserted into the Igor bus port. Another mode I want to bring up that the Igor nodes operate in, and these are common across all of the Igor nodes, they're not specific to Rev 5, Rev 6, is emergency mode. So obviously this applies to the Igor UL924 listed emergency nodes. It's going to be kind of a tongue twister there, but with the red labels, from the factory, those nodes know that they are an emergency node, and so they expect to hear a heartbeat signal from the gateway software every second. And so if they don't receive that heartbeat signal, then they will automatically go into their emergency lighting mode, which means that they will turn on any connected LED fixtures at 100% dimming level, or that can be adjusted down via the gateway software. But to meet UL 924 requirements within 5 seconds, which actually like NEC or NFPA really just requires it within 10 seconds. But since we do quite a bit of international business, some other countries are a little tighter on that time frame, require 5 seconds to turn those on. So we just designed the system to get those emergency lights turned on within 5 seconds. But these same nodes, during in normal mode, when they're not in emergency mode, would operate just the same as our non-emergency nodes. You can dim them 1 to 100%, same control, etc. You wouldn't know the difference until there was a loss of building power, and then these emergency nodes and their corresponding lights would come on to the program dimming level. And the last mode I'm going to discuss is what we call offline mode, and so that's really designed so the lights will always fail on. It takes a little bit longer for it to kick in. So say if you had a network outage or some type of issue, within 150 seconds, that node will, after not receiving any communication from our gateway server, it will go into its offline mode state and turn its lights on. And so the intention of this was that a building wouldn't go dark, that occupants could still have light to get to get work completed, get work done. And you do still have some local control via motion sensors and wall controls specific to the daisy chain of the individual nodes. And then once that network connection is reestablished, then those lights, those nodes will automatically return to the state of that lighting control space. I'm going to kind of go quickly through these last couple because we're getting up on 20 minutes to the end of the hour. So back to our technology stack here. So I'm going to cover just a couple slides, getting in to some examples, some other examples of those low voltage devices that can be connected to our nodes. You can see at the bottom of the slide here, we've got some sensors, luminaires, wall controls, some actual plug load control. These are some nice looking wall outlets that essentially have the relay built into them. You can wire those directly to an Igor node and actuate them on and off based upon plug load control. And then of course motorized shades. And going back to the LED fixture agnostic standpoint, here's an example of some of the OEMs that we've worked with on pairing our Igor nodes with their fixtures for projects and such. So that list is ever growing. And a couple other examples of just some of those low voltage 24 volt DC devices. So these are some of the more common ones that you would connect to our nodes. But so that's the end of presentation. I'll let Kim take over for a second here, and then we'll start the Q&A.
Excellent. Well, thank you so much, Andrew. We've certainly been getting a lot of questions, and we are going to power through as many as possible in the remaining time. We will send an email after in a couple of days. You'll get a link to this, to the recording of this, and more information on, you know, next steps and other things you might be interested in. So, first question: can you mix Rev 5 and Rev 6 nodes?
That's a great question. Yes, absolutely, absolutely. We've made our nodes, or made sure to make our firmware and make our nodes cross-compatible. So I was actually just doing some testing the other day, alternating Rev 5 and Rev 6 nodes in a daisy chain, and there's no issues at all. It's all treated the same.
All right. Can you daisy chain device nodes and emergency nodes?
You certainly can. Yep, that's really probably not a scenario that we had planned for or would typically design. Usually we like to segregate the emergency and non-emergency nodes since the power sources, the PoE PSEs between those would be on emergency or non-emergency power. So it's certainly, you know, the system's compatible for that, but it's probably not a common scenario we would recommend.
We've got a couple questions, so I'm going to combine them, and these are regarding CCR, PWM versus hybrid. So what type of fixtures use CCR versus PWM versus hybrid? How do you know which fixtures uses which? And then are there advantages to one over the other?
Okay, sure. You know, it really, I wouldn't say that the different dimming control types, at least from what we've seen or what we've experienced, have differed based upon the fixture type. I would say probably 95 or 99.9% of our installations use the hybrid dimming mode. You know, it takes advantage, or, you know, it uses the advantages of both CCR and PWM. You know, one of the drawbacks traditionally of PWM was that PWM buzz or that hum, you know, and so that's why at the top end, the top 90% of the dimming in hybrid mode, that we're using CCR. There's no hum, there's no buzz, but with that 12-bit DAC, we still have that fine-grained control. So we can gradually fade the lights from one dimming level to the next without getting stair-steppy and without the occupants being distracted. PWM traditionally can offer very smooth dimming, but has the disadvantage of the hum sometimes. So with the hybrid mode, like I said, that's really probably our de facto standard anymore. It really takes advantage of the best of both worlds there.
Okay. From Rajesh, what would be the IP rating of these nodes? Would they be predominantly sitting above the ceiling? And is there any heat generation within the node?
That is a great question. I know it's on I brought up some of my data sheets. Let me see. I don't remember it offhand. Oh, I thought I had it in here. Okay, so yeah, so we were going for an IP20 rating. You know, so these really, they're not rated for damp environments. Typically, if you're going to power or drive some external fixtures, you know, some soffit fixtures on the outside of a building, you know, the node would probably be mounted in a junction box on the inside of the building, or in some type of seal type box if it has to be exterior to the building. But you know, IP20 really just gives us, you know, some dust protection. It keeps somebody from, you know, poking their fingers around in a node and touching the circuit board and such. So so yeah, all of our data sheets have that, but it's pretty much IP20 across the board for our node lines.
Great. Chris is asking, what's the expected life cycle of a node before expected failure or needing to be replaced?
Sure, yeah, and that's where we partnered with Hubble Lighting, and they put, I think it was like 100 of our nodes through their environmental test chamber, and did the analysis and provided us the report on the expected lifespan. And so that's where it's it's really 15 to 20 years of expected lifespan or mean time between failures. So very good lifespan. One of the reasons for that is there's just less heat being generated inside the nodes. Your pure DC to DC conversion. There's no AC to DC conversion like traditional line voltage drivers. So you're getting that much less heat generated. You've got some efficiency improvements because of that. So that really helps our nodes live a long time. I mean, I've been here at Igor, coming up on 6 years, and once we've got a project installed, up and running, it's very rare, if ever, that we have a node fail.
Let's see. From David, when you have daisy chained nodes, is there only one IP address assigned to the first node? So does that mean that the rest of the nodes have no IP address?
Yeah. So yep. So there's just a single IP address for that whole chain. But within the Igor firmware, and thus back at the gateway server software, each of those connected devices, whether they are a light fixture, aux sensor, wall switch, they receive a unique ID within the Igor system. And so they are all discovered and assignable as individual devices. So, the limit I gave of 32 device limit on a daisy chain, if you actually programmed a 5-node daisy chain with all those devices, you'd have 32 devices show up at the gateway, but yet they would all fall under the same IP address there. So that limits the scope of your subnets and the IP address ranges you need to coordinate with the customer's IT department.
Great. Now we've got two sort of similar questions from Bruce and from James about what happens if the server or the gateway goes down. Do the nodes assume it's an emergency event? What's the fixture status?
Yeah, yep. So what's going to happen? So for the non-emergency nodes, after 150 seconds, they're going to go into that offline mode. And so then they're going to turn on any connected fixtures at that adjustable offline mode dimming level. It's that by default is 20% right now. But once the project's commissioned, that can be bumped up to 100% or whatever the owner wants to configure it for. So and in that same scenario, the emergency lighting nodes within 5 seconds will go to their emergency mode dimming level. And so that's default to 100%, but is user adjustable as well. So the overall theme is hey, we want the system to default to the lights turning on. We don't want a building going dark. We don't want the occupants to be disrupted if there is an issue. So yeah, that's what's going to happen.
Great. From Jose Maria, how do you protect the LED luminaires in the case of an overcurrent on a program failure? Is current control only via software?
Yeah, and well, so that typically the nodes will be programmed for a certain max current based upon the fixture they're being connected to. And so whether Igor does the programming, whether one of Igor's partners does the programming, or if the fixture manufacturer does the programming, somebody's going to make sure that maximum milliamp level is set correctly, whether it's 700 milliamps, 1,000 milliamps, 1,400 milliamps. It's going to be set so that essentially the 100% dimming level corresponds to that milliamp level. So if it's 700 milliamp fixture, node's programmed for 700 milliamps, and at a 50% dimming level, that node, depending on the curve type selected, is probably around 350 milliamps or so. But ultimately, that's the key item is making sure the node is programmed correctly for the fixture it's going to be paired with.
Great. From Orlando, would you recommend that the network is isolated, or can they reside on the customer's network?
Oh yeah, that's another great question. And we see, we've seen both scenarios. I would say early on, we've seen more isolated, whether physically isolated or subnet isolated networks. We usually don't see them intermixed on the same corporate network, same subnets. Most customers want to have a lighting subnet, whether it's physical or a VLAN and such. And so that's typical what we would recommend, is that the lighting network is separated out from the corporate network, either physically or via VLANs.
Okay. Real quick, a reminder to the audience, you can give thumbs up to other questions. That helps bump them up. So in our limited time, we can prioritize questions that everyone wants to listen to. So remember that option if you want to help move any to the top in the last couple of minutes. This one's from Mike, simply asking, what is the warranty on these devices?
Yep, they carry a 5-year warranty on all of our nodes. So just typical industry standard warranty.
And then, so I'm going to ask this for Rajesh and just read it, and hopefully this makes sense to you here, Andrew. So in the 90 watt plus, will there be the same number of LED modules for sensor 2, wall switch 1, or are there increments on the number of elements to be connected?
Let's see here. I guess maybe I'm not totally understanding it, but I'll comment on it a little bit. In a 90 watt plus scenario, you could have, say, just a single node with, say, 2 40 watt fixtures connected to it, or 1 75 watt fixture connected to it. Or you could have a daisy chain of nodes with, say, 4 20 watt fixtures connected on the daisy chain, or 10 8 watt fixtures connected, or et cetera. You can mix and match. You've got a lot of flexibility. It's really that power limitation that you just have to pay attention to, so that you don't overdraw that port. And Igor, we do a lot of testing with different manufacturers, PoE, power sourcing equipment. And one of the things we do test for is, to make sure that we can get that maximum power per port that it's rated for out of it. But then we also test to see if it gives us a little bit of extra headroom. So if it's one I ran into recently was rated for 90 watts per port, but I could actually push it up to 95 watts per port. That's not something that the manufacturer publishes, nor would we publish, but it does give you a little bit of headroom there if in your lighting design you're really pushing the limits of the home run's capability.
Great. Mike is asking, how and when do you program the nodes to match the fixture's milliamp current?
Sure. Yep, that's a great question. And what from my experience, I would always make sure, or always recommend, that the nodes get programmed before they get to the project site. So depending on if those nodes are going through an OEM manufacturer, that OEM should be programming the nodes before mounting them in the fixtures. If the nodes are coming directly from Igor or from one of Igor's partners, we definitely recommend doing some pre-staging of the nodes as much as possible. So programming them for the right milliamp levels, and labeling them, of course, programming them for the sensors or wall switches that will be connected to them, and labeling them that way, of course, because that just makes everything go so much smoother down the line if it's pre-staged, pre-programmed, kind of plug and play at that standpoint.
Great. David's asking, so based on some of your answers earlier, he's asking if you can mix Rev 5 and Rev 6 nodes on a daisy chain and connect it to a 90 watt port switch. Will the Rev 5 nodes get damaged?
Oh, no, they really, I mean, it would be probably a rare scenario. So how that would look, you would have to use a Rev 6 linear node network, linear node, Rev 6 linear network node, in order to get that 90 watts plus from the port. First of all, if you plug a Rev 5 network node into one of those switches, it's only going to grant you 60 watts. So you've got a 90 watt network node, and say for whatever reason that network node is consuming, I don't know, less than 30 watts. Well, the key is that it's all based upon power draw. It's not like the PoE switch is forcing 90 watts down there. It's just able to grant or able to supply up to 90 watts. So, you know, you would have to have, say, a daisy chain of a couple Rev 5 nodes coming off of there with a total lighting load in excess of 60 watts. But even then, I've ran Rev 5 nodes. Don't hold me to this from a warranty standpoint, but I've ran Rev 5 nodes at 85 watts before for weeks on end, and they ran fine. You know, so
Not recommended.
not recommended. No, don't hold us to that. But you know, we have tested some of these scenarios, and we have had requests on bumping up the Rev 5 line from 60 watts to 90 watts, which is something that we're actively looking into, because a lot of people like the Rev 5 design, but want the higher power available. So that is something that will most likely be available in the future.
All right, we've got a couple that should be pretty easy to run through in the last couple of minutes here. So from Victor, will the emergency nodes work with integral backup batteries?
Not yet. Not yet. That was our intention with the Rev 6 line, was developing an integral local on-fixture backup battery. That became more complicated than we had originally thought. So we're still, you know, we haven't given up on the idea, but right now they're really just based upon that centralized generator UPS inverter backup power.
Great. From Sean, he's asking if there's any integration with Honeywell's BACnet devices.
We do offer a BACnet over IP add-on service. This would be at the gateway server, and so that is an additional, I don't want to call it a plugin, but an additional service that can be added to our gateway software that will expose the lighting network as BACnet objects via BACnet over IP. And so that will allow a third-party system, you know, Honeywell, Johnson Controls, et cetera, HVAC system to read data values such as occupancy status or temperature of lighting control spaces, as well as send lighting commands through that BACnet interface. So turn lights on and off, adjust dimming levels. If an owner wants say a centralized single schedule for their building, they could set it up, say, in their HVAC system and command both the HVAC set points and the lighting through that one schedule.
All right. You know, with a few questions left, I am fine going a couple minutes over if you are, Andrew.
Yeah, absolutely.
Try to get a few more answered here, understanding that if anyone needs to drop off, please do so. The recording will include all of these bonus questions in this bonus time.
Bonus time.
Bonus time. So from Bruce, do you offer ceiling enclosures to aggregate nodes in a neat ceiling package?
Let's see. Can you repeat the question? You cut out for a second there.
Sure. So from Bruce, he's wondering, can you do you sell a ceiling enclosure so you can aggregate nodes to a neat ceiling package?
Okay. That's a good question. We don't offer that. You know, depending on the type of look you're going for and such, there may be some different, you know, if it's standard electrical boxes that multiple nodes could fit into, something like that, I'm sure is available out on the market. But I can't think of any projects where Igor has supplied that.
Right. Do you have a recommended fixture wiring label plan for that the manufacturer should adhere to?
Oh, that's an interesting question. I'm not sure if I've been asked that before. Usually we leave that up to the OEMs, to the fixture manufacturers, for that.
We work closely with OEMs.
Yeah. And I feel like maybe there's some more to that question that I'm just not thinking of. So feel free to follow up with us on that if there's a specific scenario you're thinking of, if it's multi-channels, I assume, or something like that.
Do large installations typically keep some nodes on shelf just in case something happens? What steps are required to replace a node?
Sure, sure. Yeah, you know, it's typically recommended, you know, especially on larger installations, to have a couple spare nodes available just in case. You know, one of the key things along replacing a node, at least for right now, we're working on automated software methods to make this easier in the future. But for right now, similar to how you typically have as-built drawings at the end of a project, you would want to store kind of your as programmed configurations for the different nodes on your network. And that's easy enough using some of the software tools that we've developed. In the future, we are looking at developing more of an automated system for that, where the gateway server would automatically pull down the configurations of all those nodes. And then if it noticed that a node on a certain home run was replaced, it would prompt the user to, you know, update the programming in that node to what the previous node had in it, such. So, yeah, so lots of like lots of things with Igor, where we're always improving, adding new features, etc. So that's something that's on the roadmap.
Okay, there are still a lot of questions. I'm just not sure we're going to be able to get to a whole lot more today. But we're going to take these questions and take a look at them, just like all the questions I've been unanswered so far. And we'll see what we can do in terms of producing content that helps. We'll incorporate a lot of these into our future Igor University and other webinars as well. I'll definitely share them with Andrew. And we'll see what we can do, if we can even answer a few maybe and include them in an email that we'll follow up with in a couple of days. So thank you all for your time today. I know we appreciated it. There's been a lot of good interaction in the Q&A section, and thank you to Andrew.
All right. Well, appreciate everybody joining. Appreciate all those good questions. And like Kim said, we'll try to follow up with as many as we can.
All right. Take care and join us next week if you can. Have a good day.
Thank you, everyone.